Hi, my name is Braden and my cameraman is Hayden. And today we're going to be looking at the MAF and MAP sensors on a 1999 Buick Sabre with a 3.8 liter V6.
Taking a look under the hood, on the right you'll find the MAF sensor, and then on the left side of the intake manifold you'll find the MAP sensor. Taking a look here at the wiring diagram for the MAP sensor, you can see you have a 5-volt reference line coming from the PCM. That'll be a gray wire. And then you have your signal back to the PCM. That's going to be a light green wire. And then you also have a ground wire that goes to the PCM. That will be an orange and black wire. With the key on engine off, we got 4.8 volts on the MAP sensor signal wire. At idle, we're seeing about 1.2 volts coming off the MAP sensor. And then you can see we also have a vacuum gauge hooked up. With the vacuum gauge hooked up, it allows us to see what our pressure in our intake manifold looks like relative to our MAP sensor reading, which allows us to compare the two readings to see if they're correlating correctly. While the MAP sensor is working correctly at the moment, we found that it actually had a problem with the wires going to the MAP sensor. We found there was a break in the wires, and so when wiggled, sometimes they would lose continuity or lose connection, causing a intermittent fault with the MAP sensor. When the engine is shut back off, you'll be able to watch the voltage go back to 4.8 volts as the pressure in the intake manifold returns back to atmospheric pressure. We found the break in the wires to be right at the connector for the MAP sensor, where they come out of the connector.
With our MAP sensor live data pulled up, you can see that voltage is relative to pressure. When pressure goes up, voltage also increases inside the sensor. You can see when I give the throttle a good tap, the voltage spikes to about 4.5 to 4.6 volts. And then when I let off, the voltage drops and the pressure also drops inside the intake manifold.
Looking at the wiring diagram for the MAF sensor, you can see there's a pink wire that's coming from the fuse block. That's just 12 volt source power with key on ignition. And then there's also a ground wire that will be black and white. And then we have a signal wire that's yellow that has a 5 volt pull up resistor. So if the wire's disconnected, you'll see 5 volts on this line. When testing the signal wire on this vehicle, we also found that the signal back to the PCM was a digital signal. This means to see the readout of the MAF, you have to measure the frequency output in hertz. Taking a look at our multimeter set to hertz, you can see that we're getting around 3.3 kilohertz at idle, meaning that the signal going back to the PCM is switching on and off more than 3,000 times each second. As the engine RPM changes, you'll see that the frequency also changes. This is because as engine RPM increases, it draws more air into the engine, which causes more air to flow across the MAF sensor, which causes the frequency to then change.
Alright, so we have our live data pulled up for the MAF sensor. You can see it's reading the engine speed, the frequency of the MAF sensor, and the amount of air that is coming through the MAF sensor in grams per second. You can see when I goose the throttle, the frequency of the sensor increases and the amount of air that's being pulled into the engine is also increasing. We also have our MAP live data pulled up as well, just as a relative comparison. We also pulled up a few graph views on the scan tool to give an easier visual for the viewer to see the increases and decreases of the throttle response and what the MAF is seeing. After looking at our scan tool, we hooked up the MAF sensor to a picoscope, and let's see how it looks on a graph. With our MAF sensor hooked up to the picoscope, we can see that we're reading in square waves. And with this, when the throttle is increasing, the frequency is also increasing, so the square waves tighten up. And when we are off the throttle, these square waves decompress and loosen up.
Taking a look at a slightly different picoscope setup, we have the MAF and MAP sensor connected, and you can see how the MAP sensor and the MAF sensor change at the same time. The MAP sensor is analog, so you won't be able to see much, but you will be able to watch the voltage change as the frequency changes on the MAF sensor. The MAP sensor is represented by the red line, and the blue is still the frequency of the MAF sensor.